Hello everyone and welcome to my channel. Today's video is going to be over two-digit multiplication. I will talk with you about the picture representations that you can make from multiplying double-digit numbers. This video is accompanied by student note pages. If you would like to access the student note pages, please look in the description and click on the link. Let's begin. Now, when I multiply two-digit numbers, each number has a name. Let's take this multiplication equation, 10 times 12. Well, I know that the answer is 120, and the 10 and the 12 have a name. The first number in a multiplication equation is called a factor, the second number is a factor, and the answer is called a product. That's going to matter whenever we talk about these models later in the video. When we multiply numbers together, we can use picture representations of ones, tens, and hundreds. Now, we're going to use these symbols to represent multiplication models. We're going to use ones, tens, and hundreds. Now, when we represent the ones, they can look like either of these two symbols, basically a small square or a unit. Tens can look like a 10 stick or a rod, or a long skinny rectangle, and a 100 flat can look like the hundreds that you can see each unit inside of it, or just a simple open square. So these particular pictures are going to be what we use to represent multiplication models later in our lesson. Okay, now let's talk about area models. An area model is a square or rectangular representation of multiplication. Area models show the partial products in groups of hundreds, tens, and ones. Now let's look at these examples and we're going to talk about what this means. So let's take A, 13 times 14. Now I want an answer to this problem, but I want the answer as a picture and I want it as numbers. So first we have to take the number 13 and we're going to expand it. 13 is actually 10 and 3. Now let's take 14. 14 is actually 10 and 4. Now, the 10 and the 3 show up in this picture. Let me give myself some more space here. The 10 and the 3 are here. 10, 3. And for 14, I'll use this 10 that I already have, and 4. Now watch this. What is 10 times 10? Well, that's 100. There is my 100 right there. What is 10 times 3? That's 30. Do you see 30? Right there. How about this 4 times this 10? 4 times 10 is 40, and it's represented here with these 4 tens down here. And then the last multiplication that's happening here is this 4 times this 3. And 4 times 3 is 12. And you see 12 represented here. So you have 100 represented in 100 flat. I have 30 with 3 tens, 40 with 4 tens, and then I have 12 ones. Now, this whole model represents 13 times 14. So I have to take these numbers, 100, 40, 30, and 12, and I add them up. Now you can probably do this with mental math, and when you add up those numbers, you get an answer of 182. So your answer is the picture, and it is the numerical answer of 182. And both of these representations, the numerical and the model, is what you're going to have to do on the next few examples. Now let's look at B. Again, I have 12 times 15. So hopefully you're looking at this picture with kind of different eyes and you're seeing the hundreds and the tens and the ones. Now 12 is a 10 and a 2. 15 is a 10 and a 5. Okay, so let's do our multiplication. What is 10 times 10? That's 100. How about this 10 times that 2? 10 times 2 is 20. Here's my 20. my 100, and my 20. How about this 5 times this 10? 5 times 10 is 50, and I have 5 tens represented here. And then this 5 times this 2, 5 times 2 is 10, and here is my 10. So again, I add these together, 100 plus 50 plus 20 plus 10, and my answer is 180. So I have my numerical answer, and I have the picture that represents the multiplication. Now let's look at C and D. Now as you can see, the multiplication equation is blank, but you have the picture, so the picture should be able to give you the numbers. Well, here's what I see. I see 100, and I know that 100 is made from 10 times 10. I see 40, and I know that 10 times something gives me 40. Well, what's the something that gives me 40 times 10? It's 4. Okay, I see here that I have 50, 5 tens. So this 10 here times something gives me 50. 10 times what is 50? Well, it's 5. And then the very last part are these ones. Now that I have my numbers, I know that 5 times 4 is 20, and that last section is 20. So when I add these numbers together, 100 plus 50 plus 40 plus 20, I will have my answer. Can you tell what the original equation was? The original equation was 10 and 4. What is 10 plus 4? That's 14. And then 10 and 5. What's 10 plus 5? That's 15. And when we add up each part of this answer, those are my partial products, I get 210. Let me squeeze that in here. 210 is my answer. Now, look at D, and you're probably able to solve this a little faster. You have 100, 10, you have 70, and 7. Do you think you can solve D on your own? What is the original equation, and what are the parts of this model that will help you find the answer? Take your time and try to solve D on your own. Now we're going to talk about array models. An array model is a square or rectangular representation of multiplication. Array models show the multiplication in groups of hundreds, tens, and ones. But in array models, you can count every single unit one by one. And that's what makes array models a little bit different from area models, although you can see the multiplication pretty clearly on both area models and array models. So let's look at these examples in front of us. Let's start with E. I have 15 times 17, and now that you've had a little bit of exposure to what these models represent, this model here will probably make a lot more sense to you at first glance. Now, 15 is 10 and 5. 17 is 10 and 7. Do you see the hundreds, tens, and ones now? 10 times 10 is 100. 10 times 5 is 50, and here is my representation of 50. I have 5 tens. This 7 times this 10 is 70, and I have 70 represented here. And then 7 times 5 is 35, and I have 35 ones in this part here. So these are my partial products, 100, 70, 50, and 35, and when I add those together, I get an answer of 255. So I have my numerical answer, and I have my picture representation. I have my array model. Remember, on array models, I can go through and I can count every unit one by one. That's what makes them a little different. Okay, now let's look at example G. Now on this one, you see that you're actually missing the equation, but you have the picture, and that should help you to go backwards and get the equation. So here, I see that I have 100. And what two numbers give me 100? 10 times 10. Now I know that other numbers give me 100, but that's not what the model's represented, because when I count my units one by one, I see that there are 10 in the top row and 10 in the first column. Now, in this column, I see I can actually count them. So when I count one by one, all my units here, I have 6 columns. So 10 times 6 is 60, and that's what's represented in that part of this model. Now look at the next part here. You only have one row of 10, so that's 1, and 10 times 1 is 10. And in the very last part, I have 6 ones, and I get those numbers by this 1 times this 6. So that little part is 6. So here are my partial products: 100 plus 60 plus 10 plus 6. When I add those numbers together, I get a final answer of 176. Now, what were the original factors that gave me 176? Well, I see at the top I have a 10 and a 6, and that is 16. On the left, I have a 10 and a 1, and that gives me 11. And 16 times 11 gives me a product of 176. Now that you've had exposure to area models and array models, why don't you try and solve F and H on your own? Now let's talk about multiplying two-digit numbers in different ways and using different representations. Multiplication can be represented using different pictures or models. Be sure to label the models and use a different color for the hundreds, the tens, and the ones. When the entire area of hundreds, tens, and ones can be seen, we call that an area model. And here you have some area models that represent a multiplication equation. But these models look bigger. They have more hundreds, more tens, and more ones. But the method that I taught you earlier in this video is the same. So let's look at these models. Here I see that I have 100 and 100. Well, what two numbers in this model type make 100? I know that it's going to be 10 here and 10. 10 times 10 equals 100. Well, this time, this 10 is also going to multiply here times this 10 to give me this 100. And I see that I have one 10 stick right there. So this 10 times that 1 is 10. Okay, now I have some 10s at the bottom. I can see that I have 30, trying to write tiny here, and I have 30 here. So this 10 times what gives me 30? Well, 10 times 3 gives me 30. And then this 10 times this 3 gives me 30. The very last part of multiplication you're going to do here is here. This 3 times this 1. Well, what's 3 times 1? It's 3. And you see you have your 3 ones right here. Trying to write tiny. Okay, so what is the multiplication equation? Well, let's look at the top. The top number is 10 plus 10 plus 1. And what is 10 plus 10 plus 1? That equals to 21. So 21 times, and on the left I see that I have a 10 and a 3. What's 10 plus 3? That's 13. So my multiplication equation that's represented by this area model is 21 times 13. And can you, in your mind or on a scratch sheet of paper, add all of these partial products to find the final answer? 21 times 13, you get a total of 273. 273 is your final answer. And that is for our first model here. Okay, I'm going to erase part of this and then talk with you about the next model. Okay, so the next model is even larger. And now that you've had some exposure to models with more than 100 flat, we can do it again. Well, I know that 10 times 10 is 100. And I know that this 10 times another 10 will give me 100 again. And now I have some 10 sticks. Well, how many 10s are here? I need to count them. I see that I have 10, 20, 30, 40. Okay, well, I need to know this 10 times what gives me 40? Well, 10 times 4 gives me 40. So what we did here in the first row going this way, we're going to represent that again here. So I have another 100, 100, and 40 once again. Now what factor gave me those numbers? Well, it was a 10 right there, because 10 times 10 is 100, 10 times 10 is 100, and 10 times 4 is 40. Okay, now look at the bottom of this model. I have a lot of 10s. When I count those 10s, I count 10, 20, 30, 40, 50, 60, 70. And I have 70 in this part. So think here, 10 times what gives me 70? Well, 10 times 7 gives me 70. And this 10 times this 7 gives me 70 once again. So the very last part of this model is going to be this 7 here times this 4 here. And what is 7 times 4? It is 28, and I have 28 ones right in that little section. So I have my model, but I don't have the original equation. So let's look for that original equation. So at the top, what is 10 plus 10 plus 4? That is 24. I'm going to write it over here, times. Now let's look on the left. 10 plus 10 plus 7. Well, that's 27. And you can add these up, your entire model, to get your answer, or you can just multiply. What is 24 times 27? And when you add up all of those hundreds, tens, and ones, you should get an answer of 648. And that is your answer to this model. It's an awfully large model, but it still represents double-digit multiplication. Okay, I'm going to erase this part here. I would love for you to do this example on your own. Now, let's look at the bottom examples. When you count every single unit one by one, we call that an array model. And these down here are array models. Now, they look a little bit different, but just the same, you can count the units to find the answer. Now on this model here, you can see that you have part of it grayed out and you have the grid in the background. So here I see, if I count these units, I have 10 times 10, and that gives me 100. Another 10 times 10 gives me 100 again, but in this little section here, I only have 2 columns, and that would be 20. So 2 times 10 is 20. Now let's look at the bottom. This 10 times 3 gives me 30. This 10 times the 3 once again is 30. And then the last part we have is here. 2 times 3 is 6. And I have 6 units in this last little section. So when I add these together, I get a final product, but what was my equation? Well, I know that 10 plus 10 plus 2 is 22. And I know that 10 plus 3 is 13. So my original equation was 22 times 13, and I can multiply this, or I can add all of the numbers from my model and get a final product of 286. That is my final product for that model. Now let me erase this part here. And let's look at the second model. I have 10 and 10. And that gives me 100. Now count your units, because it almost looks like 100 in the next part, but it's not. When you count the units one by one on this part, you will see that you have 9 columns. So 9 times 10 is 90. And this one is a pretty quick answer. 100 plus 90 is 190. That's my final answer. And what are my factors? Well, 10 plus 9 is 19 times 10. And 19 times 10 gives me a final product of 190. Now, take your notes and try to solve this one on your own. It's another array model, and you can clearly see that it has quite a few boxes, but you can figure it out using the units. Okay, so we're going to talk about two-digit multiplication, but this time using partial products. And here's what that means. Whenever you have an answer in a multiplication problem, it's called a product. And we're going to talk about the parts of the answer, or the parts of the product, that we encounter as we're solving. So let's take a look at 15 times 17. Well, first I have to expand. 15 is 10 and 5. 17 is 10 and 7. After I expand my numbers, I'm going to multiply. Now, I'm going to multiply like this. 7 times 5 is 35. 7 times 10 is 70. Now I have two numbers, and these two numbers are my partial products. Now let's multiply the 10. 10 times the 5 is 50, and 10 times 10 is 100. Now I have four numbers. When I add these numbers up, they are going to give me my final product. But as they're separated here, these are my partial products. They're part of my final answer. So the last step in multiplying this way is to add. And I tell my students, when we add, you add faster and more accurately if you add up the numbers in greatest to least order. So I have 100 as my larger number, and then I have 70, 50, and 35. Greatest to least order. Now let's add these up, and when I add these up, I see that my final answer is 255, and that is my final product. Make sure you put your final product here. Let's do one more example together, and remember, our steps are to expand, multiply, and add. Okay, my next numbers are 42 times 25. Now first I have to expand. So 42 is going to be 40 and 2. 25 is going to be 20 and 5. Let's multiply. Okay, 5 times 2 is 10. 5 times 40 is 200. Okay. This 20 times that 2 is 40, and this 20 times 40 is 800. Okay, now I've multiplied. Now I have to add them up, and I like to add them in greatest to least order. So I will take 800 plus 200 plus 40 plus 10. And you might even be able to do this using just mental math. Now when I add them together, I see that my final answer is 1,050. And I will write that here in my original equation. And this is multiplying using just partial products. Now let's have you guys do the final two examples C and D on your own. Now, the final double-digit multiplication strategy I'm going to talk with you about in this video is something called box method. Now, box method and partial products are very, very similar. The only major difference is that in this way of solving, you're going to put your work in a box. So, we do the same steps. We expand, multiply, and add whenever we multiply this way. So let's take the example 13 times 42. Well, first I expand 13, and I have 10 and 3. And I expand 42 to 40 and 2. And here's what I do with those numbers. I take the 10 and the 3, and I put it on top of the box here. Then I take 40 and 2 and put it to the left of the box. Now, I could switch them if I wanted to, but I try to tell my students to use the exact same numbers in the same places every time, just so they can kind of get a rhythm in their solving. So I always say that the top number, my first factor, goes at the top, and then the second factor goes on the left. Okay, so now it's time to multiply. What is 40 times 10? Well, I know that that's 400. And 40 times 3, that's 120. Okay, how about this 2 times this 10? That's 20. And the same 2 times the 3. Well, that's 6. Now I have 4 partial products, and my last step in solving is to add them. Now, I like for my students to add in greatest to least order. It just helps to avoid error and get the answer a little quicker. 400 plus 120 plus 20 plus 6. And when I add these together, I get an answer of 546, and that is my final answer. I'm going to put it back in my original equation, and that is box method. So let's do one more, and then you can do the final two on your own. 22 times 37. Well, first we have to expand. So 22, I know that that is 20 and 2. And then I have 37. That is 30 and 7, and this is where they sit on my box. Now let's multiply. 30 times 20 is 600, and that goes in my first box. 30 times 2 is 60. Now I'll multiply the 7. 7 times 20 is 140, and this 7 times that 2 is 14. Now, my last step is to add, and I'm going to add in greatest to least order. So I will add 600 plus 140 plus 60 plus 14. And when I add these numbers together, I get a final answer of 814, and I will put that back into my original equation. Now answer G and H using box method on your own. I hope you found this video over double-digit multiplication helpful. If you'd like to see more helpful math videos, please like and subscribe to my channel. Thank you for watching and have a great day.